Hello everyone, good evening. So in this video, we shall solve some more KCET previous year questions on the chapter Ray Optics and Optical Instruments. So any doubts if you have, then please write us in the comment section. We shall clarify them in the subsequent videos. And in any other chapter, if you feel more difficulty, then please write the name of that chapter in the comments section. And some important homework questions on every chapter be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So in this, so here we shall start from the very first question. In the first question, it is told that the blue color of sea water is due to. So it is due to the scattering of sunlight by the water molecules. It is called the Rayleigh scattering. So according to the Rayleigh scattering, know that the intensity of the scattered light is inversely proportional to the fourth power of the wavelength. So now in the uh, spectrum of the visible light, we have VIBGYOR, means violet, indigo, blue, green, yellow, orange, red. So the blue color is um, more scattered than the red. Since the wavelength of red is more than the wavelength of blue, so the blue color will be less scattered. So sorry, the blue color is having lesser wavelength, so the intensity of the scattering of blue will be higher. So the blue color is more scattered than that of red. Blue color is more scattered, and red color is less scattered. Red color is scattered, less scattered. So since blue color is more scattered by the water molecules, so the sea water appears to be blue in color. Option D is the correct answer. Then in question number 2, it is told a ray of light enters from rarer to denser medium. From rarer to denser medium. So it will bend towards the normal. Means that R is less than I. Angle R is less than angle I. This medium is denser. Then the reflected and the refracted rays are mutually perpendicular to each other. So here there will be always some partial reflection also. So this is the partially reflected ray. This is I, and it is told that the reflected and the refracted rays are mutually perpendicular. Their angle is 90 degree. Then the critical angle for the pair of media will be how much? So for the critical angle of incidence, the angle of refraction, for the critical angle of incidence, the angle of refraction will be 90 degrees. So therefore, the critical angle for the pair of media. So here, suppose the refractive index of the rarer medium is mu1 and the refractive index of denser medium is mu2. So mu2 is obviously greater than mu. So therefore, if I apply the Snell's law, then we will have that mu1 to sine IC, that is equal to mu2 into sine 90. So therefore, sine IC, that is equal to mu2 by mu. So now from here we can see that the angle in between these two is 90 degrees. So therefore here R is how much? R is 90 degree minus I. Since why this sum should be 90 degrees. R plus I is also 90 degrees. So R is 90 minus I. So therefore here if we apply the Snell's law, then we will have mu1 sin I, that is equal to mu2 sin R. R is 90 minus I. Therefore, mu1 sin I that is equal to mu2 cos I. So therefore, I can say tan I that is equal to mu2 by mu. So therefore, sin IC that is equal to mu2 by mu1, which is tan I. So therefore, the critical angle will be IC will be sine inverse of tan I. Option C is the correct answer. 2 into sine I, mu1 sine I is equal to 2 into sine R. Sorry, for the critical angle, it should not go from rarer to denser. It should go from denser to rarer. This is something, there is something wrong. Sorry. Should go from denser to rarer for the critical angle of incidence. This is IC and this is 90. So I can say that mu2 sine IC that is equal to mu1 sine 90. So sine IC is mu1 by mu2. So mu2 by mu1 is tan I. So therefore I can say that cot I will be mu1 by mu2. This is cot I. So sine IC equals to cot I. So it means that IC will be equal to sine inverse of cot I. So it means option C is the correct answer. Then in question number 3, it is told that a fish in water having refractive index n. A fish is inside water. A fish is there inside water. The water refractive index of the water is n. Looks at a bird. Looks at a bird. Looks at a bird vertically above in the air. If y is the height of the bird and x is the depth of the fish from the surface, so y is the height of the bird from the surface of the water and x is the depth of the fish from the surface, then the distance of the bird as estimated by the fish will be how much? So the distance of the bird, so y is the real height, so we have to find the apparent height. Therefore the apparent height that will be equal to the real height divided by mu relative, means that the refractive index of the air by the refractive index of water we have to do is 1 by n. So it means the apparent height of the bird um, as estimated by the fish, it will be equal to n times the real height, which is n times y. So therefore the distance of the bird as estimated by the fish, therefore the distance of the bird with respect to the fish, that will be equal to this x plus the apparent height with respect to the fish, that is x plus ny. So option D is the correct answer. Then in question number 4, it is told the figure shows a mixture of blue, green, and red colored rays incident normally on a right angled prism. The critical angles for the materials, the critical angles for the material of the prism for red, green, and blue are 46 degree, 44 degree, and 43 degree respectively. The arrangement will separate. This arrangement will separate. So this arrangement will separate red color from blue and green. So what will happen, that we have to find. So one mixture of blue, green, and red color have been incident. Then what will happen? This will incident normally, so the angle of refraction will be 0 degree also. Angle of incidence is 0 degree, so angle of refraction will be 0 degree here. So then this angle of incidence here, this is 45 degree. So then what will happen? The critical angle for blue, the critical angle for blue is 43 degree, and critical angle for green, that is 44 degree, and critical angle for red, that is 46 degree. So it means that this 45 degree is more than the critical angles for blue and green. So blue and green colors will suffer total internal reflection. So here this ray and the red will not suffer the total internal reflection. Since why? For red, this 45 degree is less than the critical angle. So the red color will come outside. Red color will come outside. But this ray will be the mixture of blue and green. It will be a ray which is a mixture of blue and green. So it means that this arrangement will separate the red color. The red color will come out. Since red color will come out, it will emerge out of the prism. Red color will emerge out of the prism. Since why? Since this 45 degree is less than the critical angle for red. So it will not suffer TIR. Will not suffer total internal reflection. And uh, and uh, but we can say, but 45 degree is more than the critical angles for blue and green. Blue and green. So blue and green colors will suffer total internal reflection. Blue and green colors will suffer total internal reflection. Okay, so option C is the correct answer. Then in question number 5, it is told convex and a concave lens separated by distance d are then put in contact. There is a convex lens, there is a convex lens, and there is a concave lens. There is a concave lens also. They are separated by a distance d. Are separated by a distance d are then put in contact. The focal length of the combination will decrease or remain the same. What will happen? So the focal length of this combination, suppose the focal length of this convex lens is suppose f1, the focal length of this concave lens is f2, then if a parallel beam is incident on the convex lens, suppose if I assume that d is less than f1, so it means that the rays will converge, and then final ray, what will happen? This is f, so this length be, so here will be the virtual object with respect to the concave lens. This length will be this full length is f1, so this is f1 minus d. This part is f1 minus d. So with respect to the concave lens, u is the object distance is f1 minus d. So then the final v will come as final v, that is the f equivalent 1 by final v with respect to this full length of the combination by f equivalent, that is 1 by v minus 1 by u equal to 1 by f. by minus f2. So then 1 by f equivalent, that is equal to 1 by f1, 1 by f2 plus 1 by f1. And if the two lenses are kept in contact, they are kept in contact, then the equivalent focal length will come as 1 by f1 plus 1 by f2. So here this is f1 minus d. So 1 by, so f1 minus d is obviously, f1 minus d is obviously less than f1. 1 by f1 minus d will be obviously more than 1 by f1. So 1 by f1 minus d plus 1 by f2, that is greater than 1 by f1 plus 1 by f2. Means this equivalent focal length, this, so from here we can say that for the first case I can tell this is 1, this is 2. In the first case 1 by f equivalent, that is greater than 1 by f equivalent for the second case. So it means that f equivalent for the second case is more than the equivalent focal length for the first case. It means that the focal length increases. Focal length of the combination increases. Option D is the correct answer. Then question number 6 is told a convex lens is made of 3 layers of glass. A convex lens is made of 3 layers of glass of 3 different materials as in the figure. A point object is placed on the axis. Point object is placed on its axis. Is like this. Three different materials is there. So here the material is, the refractive index of this part is mu1. For this part it is mu2. For this part it is mu3, suppose. The point object is placed on its axis. The number of images of the object formed are how much? Number of images of the object. So only one object will be formed, since why? So different lenses, thin lens. So it will act like, so this combination will act like a single equivalent lens. Will act like a single equivalent lens. So only one image will be formed. Option C is the correct answer. Actually here, if we want to find what is the equivalent focal length, then we can do it by, let's suppose here the radius is r. This is, so only one image will be formed, since this whole thing will act like a single equivalent lens. Then in question number 7, it is told a convex lens made of glass. Convex lens is there, it is made of glass. It has a focal length 0.15 meter in air. If the refractive index of the glass, refractive index of this glass is 3 by 2, and the refractive index of water, that is 4 by 3, then the focal length of the lens when immersed in water will be how much? So this is the focal length in the air. So 1 by f, that we can write, that is mu1 minus 1 into 1 by r1 plus 1 by r2. So this is equal to 1 by 0.15. 1 by r1 plus 1 by r2, that is equal to 1 by 0.15 into 1 by mu1 is 3 by 2 minus 1. So this one is half. This is 0.5. This will be 1 by, so 15 5 is 75. This is 0.075. This is 1 by R1 plus 1 by R2. That will be equal to this will be 75 by 1000. 1075. So 25 3 is 75, 25 4 is 100. So this is equal to 40 by 3. 40 by 3. Therefore, this 1 by R1 plus 1 by R2 is 40 by 3. The focal length of the lens when immersed in water. Okay, so when it is immersed in water, then the focal length, let's say it is f1, that will be how much? That will be mu1 by mu2 minus 1 into 1 by r1 plus 1 by r2. So mu1 is 3 by 2, 3 by 2 by 4 by 3 minus 1 into 1 by r1 plus 1 by r2 is 40 by 3. So this will be 3 3 is 9, so 9 by 8 minus 1 into 40 by 3. So this is 1 by 8 into 40 by 3. So this is 5 8 is 40, so 5 by 3. So f1 will be equal to 3 by 5 meter. So it is 0.6 meter. So option D is the correct answer. Then in question number 8, it is told a ray of light is incident on a surface of glass slab at an angle of 45 degree. If the lateral shift produced per unit thickness is 1 by root 3 meter, the angle of refraction produced is. So it is the ray of light is incident on a glass slab at an angle of 45 degree, and then the lateral shift that is produced. This is the lateral shift. Lateral shift that is produced, that is D. Lateral shift produced per unit thickness means if the thickness is T, then D by T, that is 1 by root 3 meter. Then the angle of refraction produced is how much? Angle of refraction produced, this angle of refraction, that is how much? Angle of the emergence is also 45 degree. So this R is how much? That is being asked. So now from here we can see that this thickness, this is R, then this is I minus R, I minus R, I minus R, and this is D. So I can say that this is T and this is R. So this kind of thing is formed. This is R, this is T, this one is D. So this angle is I minus R and this is R. So I can say that this length, suppose it is L, so L cos R, that is equal to T, and L sin I minus R, L sin I minus R, that is equal to D. So therefore D by T, that will be equal to L sine I minus R by L cos R. So L and L will get cancelled. So d by t, that is 1 by root 3. That is told this is sine I minus R means sine 45 degree minus R by cos R. And if I apply Snell's law, then we will get that refractive index of refraction so from here we can say that sine A cos B minus cos A sine B divided by cos R, that is equal to 1 by root 3. Means what? So cos R, this will cancel, so sine 45 is 1 by root 2 minus this is cos 45 is 1 by root 2 into tan R, 1 by root 3. So therefore, so 1 minus tan R, that is equal to root over 2 by 3. That means that tan R is equal to 1 minus root over 2 by 3. So therefore R, the angle of refraction R, is tan inverse of 1 minus root over 2 by 3. So option B is the correct answer. Then in question number 9, it is told, according to Newton's corpuscular theory, the speed of light is lesser in rarer medium. So the Newton's corpuscular theory says the opposite statement. The actual rule is that the speed of light in any given medium is given as v is equal to c by mu, where mu is the refractive index. So if the refractive index is high, it means that it is a denser medium, and in the denser medium the speed of light will be less, since v is inversely proportional to the refractive index. And if the refractive index is less, means it is a rarer medium, then the speed of light should be higher in that rarer medium. So it is the usual rule. But the Newton's corpuscular theory says the reverse statement. So the Newton's corpuscular theory tells the opposite statement, which is that the speed of light in the rarer medium is lesser and the speed of light in denser medium is higher. So it tells the opposite. So option B is the correct answer. Then in question number 10, it is told, in fog, photographs of the objects taken with infrared radiations are more clear than those obtained during visible light, because in fog, photographs of the objects taken with infrared radiations are more clear than those obtained during visible light, because infrared radiation, since why? The wavelength of infrared is lesser than that of the wavelength of visible light. So the scattering of infrared is more. The scattering of infrared radiations is more than that of visible light. Since why? The intensity of scattering, according to the rule of Rayleigh scattering, is that the intensity of scattering is inversely proportional to the wavelength, inversely proportional to the fourth power of the wavelength. scattering of infrared is more than that of visible light. So 10, um, scattering of infrared is more than that of visible light. So it means option B is the correct answer. It means that lesser is the wavelength, more is the intensity of scattering. Okay, then in question number 11, it is told the angle of minimum deviation for an incident light ray on an equilateral prism is equal to its refracting angle. Then the refractive index of its material is. So it is told we have a equilateral prism. Equilateral prism means that the angle of the prism is 60 degree. Then the angle of minimum deviation of the incident ray, angle of minimum deviation is equal to its refracting angle. Okay, so it means that angle of minimum deviation, it is given as 2i minus a. So it is equal to a. So it means what? That 2i is equal to 2a. So I is equal to a. So the angle of incidence is equal to the angle of the prism, and we know that at minimum angle of deviation, the R1, the refracting angles R1 equal to R2, that is equal to a by 2, which is equal to 30 degree. So this is 30 degree and this is 60 degree. So if we apply the Snell's law, here we have air and here we have the prism whose refractive index is suppose mu, which we have to find. So if we apply Snell's law here, then we will get 1 into sine A in sine I, that is equal to mu into sine R1. So sine I, so sine 60 degree, that is equal to mu into sine 30 degree. So mu will be equal to sine 60 is root 3 by 2 divided by sine 30 is half, which is equal to root 3. So option B is the correct answer. Then in question number 12, it is told a parallel beam of light is incident on a converging lens. So converging lens means it is a convex lens. A parallel beam of light, one parallel beam of light is there, which is parallel to the principal axis. It is incident as one moves away from the lens on the other side of the principal axis. As one moves away from the lens on a converging lens parallel to the principal axis, as one moves away from the lens on the other side of the principal axis, the intensity of the light first decreases and then increases. Incident converging lens, so it will be, so they will be focused on the focal point, on the focus. The intensity of light as one moves away from the lens, the other side of the principal. So then so as one moves the other side of the lens, then what will happen? First, the intensity, so first it will, so first the rays will converge and then they will diverge. So it means that first the intensity will keep on increasing and then it will decrease. So option D is the correct answer. Since all the rays will be now confined to lesser area, so when the area will decrease, the intensity will increase, and then again the area will increase, so it means the intensity will decrease. So first the intensity will increase and then it will decrease. And in question number 13, it is told a ray of light is incident on a plane mirror A ray of light is incident on a plane mirror at an angle of 60 degree. Angle of 60 degree. The angle of deviation produced by the mirror, that is how much? So this angle of refraction also will be 60 degrees. So this will be the angle of deviation. So the angle of deviation delta, that will be equal to this will be 180 minus 120, which is also 60 degree. So option C is the correct answer. Then in question number 14, it is told that a point object is kept at a distance of OP is equal to U. The radius of curvature of the spherical surface APB is CP equal to R. The refractive index of the media are N1 and N2, which are shown in the diagram. Then so here it is an example of angle. So here it is an example of refraction at a spherical interface. So here we have to apply the rule, that is N2 by V minus N1 by U, that is equal to N2 minus N1 by R. So the image is real. Okay, so what find this? So the distance OP is U. So this will be minus U actually. So N2 by V, that is equal to N2 minus N1 by R minus N1 by U. So if N2 equals to 2N1, then what will happen? Then N2 by V, that will be equal to N1 into 1 by R minus 1 by U. So if the rule is that if V is positive, then it is a real image. Then we will have real image. But if V is negative, then we have virtual image. Virtual image. So now, if R is greater than U, then it means that 1 by R is less than 1 by U. It means that then this part will be negative. So then we will have virtual image. Yeah, so so the second statement is correct. Second statement is correct. And then we have to check the first one and the third one also. So if N1 is greater than N2, if N1 is greater than N2, then this part is negative, then this part is also negative. So then we will have virtual image only for all values of U. If N1 is greater than N2, then so the first statement is correct also. And the third statement, the image is real for all values of U, N1 and N2. So that is wrong. So only both 1 and 2 are correct. So option B is the correct answer. Then in the question number 15, it is told that if A, B and C are the parallel sided transparent media of refractive index N1, N2 and N3, they are arranged as shown in the figure. A ray is incident at an angle theta on the surface of separation of A and B. The surface of separation of A and B. A ray is incident at an angle theta on the surface of separation of A and B, which is as shown. After the refraction into the medium B, the ray grazes the surface of separation of media B and C. The ray grazes the surface of separation. Okay, then sine theta is how much? Okay. So here this is N1, this is N2, and this is, so this is the critical angle actually. Okay, so this is theta, this is R. Actually, this is R, but this R is equal to the critical angle for N2 and N3. So here actually the thing is N2 is greater than N1. Since why? It is going from rarer to denser and then from denser to rarer, and N2 is greater than N3 also. Okay, so R is equal to IC. So here if we apply the Snell's law, then we will get N1 into sine theta, that is equal to N2 into sine R, which is also equal to N3 into sine 90. So N1 sine theta, that is equal to N3. So therefore sine theta is N3 by N1. N3 by N1. So option A is the correct answer. Then a boat has green light of wavelength 500 nanometer on the mast. So one boat is there, it is having one mast. So on it there is a green light of wavelength lambda, which is 500 nanometer. What wavelength would be measured and what color would be observed for this light? What color would be observed for this light as seen by a diver submerged in water by the side of the boat? By a diver who is submerged in the water by the side of the boat. So there is a diver who is submerged in the water. So what wavelength will he observe it? He observe. So this light will come in the water and then he will observe the shifted wavelength. So the wavelength of the light in the water, that will be equal to the wavelength in the air divided by the refractive index of the water. So that will be 500 nanometer divided by 4 by 3. It will be equal to 3 by 4 into 500 nanometer. This will be 4, 5 into this will be 25, 4 is 100. So 3 5 is 15, 15 into 25 nanometer, which is 15 5 is 75, 30, 375 nanometer. 376 nanometer. So we know that Vib Gear. So green colored wavelength is 500 nanometer, and so it is less than that. This wavelength is lesser, so it will be bluish. So it will be blue color of wavelength 376 nanometer. Option D is the correct answer. Okay, green color. Okay, so actually the color of the wavelength, the color of the light is uh, is given by the frequency and not by the wavelength. Okay, so the rule is, so the wavelength will change when light will go from air to water, then the wavelength will change, but the frequency will remain the same. So the rule is that color of light is determined by the frequency and not by the wavelength. Color of light is determined by the frequency, not by the wavelength. So the frequency of the light will remain the same. So the observed color will be green only. It will be green only. So the submerged diver, submerged diver will observe the green color of wavelength 376 nanometer. Option A is the correct answer. And then question number 17 is told two beams of red and violet colors are made to pass separately through a prism of angle of the prism is 60 degrees. In the minimum deviation position, the angle of refraction inside the prism will be. the minimum deviation. When there is minimum deviation, so for minimum deviation we have R1 that is equal to R2 that is equal to A by 2, so that is 60, so that will be 60 degree by 2, that is 30 degree. And here the angle of incidence, this is I, this is R. Angle of refraction inside the prism in the minimum deviation position. Minimum deviation position. Angle of refraction in the prism, that will be 30 degree for both the colors. Since for minimum deviation we should have R1 that is equal to R2 that is 30 degree for any color. So option D is the correct answer. Then in question number 18 it is told the focal length of a plano-convex lens that is F, and its refractive index is 1.5. It is kept over a plain glass plate. It's kept over a plain glass plate and its curved surface touching the glass plate. Curved surface touching the glass plate is like this. The gap between the lens and the glass plate is filled by some liquid. Here some liquid is placed. As a result, the effective focal length of this combination becomes 2f. Then the refractive index of the liquid is how much? Now, the focal length of this glass plate, that will be 0. No, the glass plate, the focal length will be infinity. So 1 by f will be 0 for this. And for this one, this liquid, it is acting like refractive index of the liquid is how much? That is asked, mu1. So this liquid part is acting like a concave lens. Therefore, its focal length, if we find f1 by f1, let's say this is f2. So f2 is the focal length for the glass slab, which is infinity. So 1 by f1, that is mu1 minus 1. Mu1, let's say the refractive index of the liquid is mu1. So mu1 minus 1 into 1 by r1 plus 1 by r2. So 1 by r1, that is 1 by infinity, minus 1 by r2. This part is so this is having radius, suppose r. This is radius r, suppose. So from here we see that 1 by f, that will be equal to the plano-convex lens has focal length f. So I can write this is mu minus 1 to 1 by r1 minus 1 by r2, that is infinity. Okay, so this is 1 by f, that is equal to 1.5 minus 1, which is 0.5 by r. So 1 by 2r. 1 by 2r is 1 by f. So r is equal to actually 2f. R is 2f here. Now r is 2f. So therefore 1 by f1. So here the effective focal length, that is equal to effective focal length, that is 1 by f1 plus 1 by f2 plus 1 by f. So this will be 1 by f1 is mu1 minus 1 minus mu1 minus 1 by r, which is 2f. R is 2f. Then plus 0 plus 1 by f. This is 2f. So this is 1 by 2f. That is equal to mu1 minus 1 minus of that by 2f plus 1 by f. The f I can cancel out. This will be mu1 minus 1, that will be equal to 1 minus half, that is half. mu1 is equal to 3 by 2. So it is also made of, so maybe this liquid is glycerin. Okay, so its refractive index of the liquid is also 1.5, which is similar to that of glass. So option A is the correct answer. Sorry, mu1, this is mu1, sorry, this is mu1 minus 1 by 2. 1 minus 1 by 2, that is 1 minus, is 1 minus half. This is half, so 1, there is something wrong here. So this is 1 by f1. The focal length of this liquid part, let's say it is f1. So 1 by f1 is mu1 minus 1 by 1 by infinity by r. This focal length is f. So I can say 1 by f is equal to mu minus 1 by r. 1 by 2r is f. R is equal to, this is f by 2. Okay. R is 2r is equal to f. So r is equal to f by 2. It means that 1 by f1, that will be equal to mu1 minus 1 minus is there by r. By r means it is, r is 2, 1 by r means it is 2 by f. So it is minus 2 by f into mu1 minus 1. So therefore 1 by the effective focal length, that is equal to 1 by f1 plus 1 by f2 plus 1 by f. So 1 by 2f, that is equal to 1 by f1 minus 2 by f into mu1 minus 1 plus 1 by f2, that is 0 plus 1 by f. So f I can cancel out. Sorry, the f's I can cancel out. So this is 1 by 2, that is equal to minus 2 into 1 by 2 f. F will cancel out. So this is 1 by 2, that is equal to minus 2 into mu1 minus 1 plus 1. So I can write 2 into mu1 minus 1, that is equal to 1 minus half, that is 1 by 2. So mu1 will be equal to 1 plus 1 by 4, which is equal to 5 by 4. So 5 by 4 is 1.25. So option C is the correct answer. It means the refractive index of the liquid is 1.25. C is the correct answer. Then in question number 19, it is told the wavelength of given light waves in air and in a medium are 6000 angstrom and 4000 angstrom respectively. The critical angle is how much? Okay, in a medium, the wavelength in that medium is 4000 angstrom and the wavelength in air, that is 6000 angstrom. Therefore, the wavelength in the medium, that will be given as wavelength in air divided by the refractive index of that medium. Therefore, refractive index of that medium is wavelength in the air by the wavelength in that medium. That is 6000 by 4000. This is 6 by 4. It's 3 2 3 are 6, 2 3 are 4. So that is 3 by 2. So this refractive index of the medium is 3 by 2. So the critical angle has been asked. So it means that when light will come from that medium to air, then the refracting angle will be 90 degree and this is the critical angle. So therefore I will write mu into sine IC, that is equal to 1 into sine 90, since the refractive index of air is 1. So mu into sine IC that is 3 by 2 into sine IC, that will be equal to 1. So it means that sine IC, that is equal to 2 by 3. So the critical angle, that will be equal to sine inverse of 2 by 3. So option C is the correct answer. So hope you have understood the solutions of these 19 questions. So here we shall end the first part of this video on ray optics and optical instruments. So in the next part, we shall solve from the question number 20 onwards. So from here, any doubts if you have in any of the steps, then please write that in the comments section. And please install our Sapience education application, where we shall upload some important homework questions on every chapter based on the previous year KCET exam. Thank you everyone. Bye.